Hello everybody. So this is just going to be a quick video on reality capture. So this is mainly for second year students. We've done the first of the photogrammetry sessions now, where we've looked at the process of photogrammetry. We've looked at a bit of the theory behind how it works. So I'll recap that in a really minimal way in this video, and we'll also go over the basics of reality capture again, just to make sure that you've got a supplemental sort of video if you want to do any of this at home. So, super quick introduction to Reality Capture. Reality Capture is free to use. You can download it from the Epic Games launcher alongside things like Unreal Engine, and it will usually ask you on launch to either sign in with an Epic Games account, or I do believe there is also a skip for now option, so you can just jump straight in. I don't know if that will have any knock-on effects about maybe limitations on exporting or how many things you can do, but I'd advise you all have an Epic Games account anyway. It's free, gives you access to software, and you can use loads and loads of different assets from the Fab Store, which used to be Quixel Bridge. Cool, so once you are in Reality Capture, this is what you're first going to get greeted with after the login. So there is a really great quick start guide which will take you through how everything works. It will tell you step by step what to do, where to put the images, what buttons to press, etc, etc. And it will also give you little information about what that step is actually doing. So you could technically follow that instead of following me. It will give you pretty much the same information and guidance. But for now, just because we're doing this video, I'm not going to use that. That would be very boring. I'm going to go up to the top left of my screen, and I'm going to click on the 1+1+1 view. And this is what we're going to get. So on our left-hand side, this is where we process any imagery. In the middle, this is where we've got our 3D view, where our models will appear. And on the right hand side, this is our 2D view, so this will give us previews of those images that we've got in our inputs list. Now, the first thing I'm going to do is I need to add a folder of images. If you don't have any images or a data set, that's okay. You can find a bunch online, and if you go into Teams, I've got one right in the files, in class materials, year 2 lessons, Connors lessons, photogrammetry, and then the Nottingham Lion photo set. I'm just going to download that entire folder. Take a second. And then all we need to do is extract this somewhere else. So I'm just going to click extract, extract it to my downloads, and then I can have easy access to it. So I'm going to go up to folder, downloads, Nottingham Lion photo set, select, and then we should start to see the images of our lions on the right hand side. Now, mine's getting some errors saying the camera is not in the sensor database. That's not going to be the worst thing in the world. Hopefully it will just be able to work around it with the information it does have, such as the model of camera, etc, etc. But the more data that you have from your camera, then the better these solves will be, and the better that it will be able to reconstruct the 3D image. A lot of the time, camera phones, they will not have as much data on them. If you do have an option to shoot as raw images from your phone, then definitely do that. It will store more of the metadata information so that the software can use that to help in the reconstruction. So, we first, once we've got the images imported, want to go to alignment. So alignment, if we click on align images, this is where the software basically looks at all of the photographs, tries to find as many features within the photograph as possible, and then tries to basically align where those cameras are based on those alignments. So I can see a lot of these little dots here. So these are the camera positions that it thinks I took the photos from, and I would say they look pretty accurate to me. We can see this point cloud here. So the point cloud is basically the extraction of those features, where it is pretty confident that that is exactly where the feature is in 3D space. We can see we've got some little bits off here at the side. You can sort of make out that arch in the background that we can see in this photograph as well. I don't want to reconstruct that. That wasn't the subject of the model that I was trying to get. So what we're going to do is, with this box that we currently have around the model, we're going to use the rotation, and we're going to use these little scale balls from each side, and we are going to just scale it around our model, making sure we don't cut off any bits that we want to keep, and making sure we cut out all of the bits that we don't need and don't want. I'm going to keep a bit of that back wall just because I think it'll look nice and it could serve as a bit of extra reference for me. There we go. So we've got the entire statue inside. We've got the bit of the back wall as well. Keep the tail, keep the paws. I'm fairly happy with that. So now that we've sort of truncated that area and cut off all the bits that we don't want, we can go to Mesh Model up at the top. Now, I work in a slightly different way. A lot of people will be too tempted to just instantly click high detail or normal detail and go, cool, I want to see it right now. I usually do preview first, just because the high detail especially can take a while and can be very intensive on the computer. So all I'm looking for when I do a preview is that everything looks like it's roughly the right shape. And as you can see at the back, I got no image coverage. If we don't have an image of an area, it cannot reconstruct it. So I just want to make sure that everything is reconstructed that I expect to be reconstructed, which it looks like it is on here. So next I can go to normal detail, and then we just wait for this to process. This will take a little bit longer to process, just because of the nature of trying to make quite a high polygon model and processing all of the data. But the high detail model will always take the longest, because it can reconstruct this data set in particular up to, I think it's something around 10 million polygons, which come out as a 1 gigabyte model. So definitely be careful. Okay, so it looks like our normal detailed model is processed, and I think this looks pretty clean. So we can see we're getting all sorts of detail. So that little cutout in the model, or in the picture where you can see the different stones that have been put together, we can sort of see some of the detail in there, which is fantastic. We can see the detail of where bits of the stone have chipped away as well. That's also fantastic. And we can also see, as much as we got coverage on the photos, that has been reconstructed, which is great. So we could just stop here. We could go, yep, that's close enough for me. That is a high enough detail model for what we want. Or we could go to a higher detail. Higher detail will do the exact same process again, but it will take substantially longer. But it will create, in most cases, a cleaner mesh with higher polygon count. I'm going to skip that step for now, just for the sake of the video. And what I'm going to do instead is just go straight to texture. So what this is going to do is automatically unwrap and then texture our model. So the texturing process in Photogrammetry is basically, it will take the positions of those cameras that it worked out, and then it will project the image that we took from that location onto the model. And it will use a lot of very clever algorithms and different software like sort of techniques to merge those images as best it can to make sure that they all look like one cohesive texture onto the model, which we should see in a second, and we should be able to see all that stony sort of texture and detail. There we go. So now we've got our textures, and we can see we've got all that detail both from the model and from the textures, which is fantastic. Got all this lovely grime and dirt on the top of the lion, and we can see it in all of those sorts of crevices and the different contours of the statue, which is lovely. Right, so when we're exporting this model for use in something like Maya, Blender, Unreal Engine, whatever it is, there are a couple of different ways we can go about it. If this is going to be a hero asset, which we've talked about before, so remember, a hero asset is something that's going to be close up to the camera and needs to be able to hold up to that extra scrutiny to make sure that it doesn't fall apart and look like obvious CGI or like a bad model, anything like that, then we could just export the full density mesh, which I'll show you how to do first. So if we go back to workflow, the first tab we were in, and come over to export, I'm going to click on export, and then we get a long list of things that we can export as, and different bits of data we can export. So we're going to scroll down until we find the dense mesh and model textures section. Now we've got a lot of different file types here. We can use these for a lot of different things. What we're going to do for now is do the wavefront object, so a .obj file. And we can just give this a name, call it lion scan. I'm going to do it with no spaces and just hit save. Now, in this export model settings, we want to make sure that in the texture settings, the export textures is set to yes. If we have this set to no, it won't give us a texture file that lines up with the model, and it'll just be one extra step where you've got to go back and redo it again. So once I've made sure that our texture export is set to yes, I'm just going to hit OK. We'll give it a second to make sure it can save all of those separate models and export the texture as well. And then that should be done. So now if we hop back over into Maya, go into import, and then just find our lion scan again. So in the Nottingham Lion photo set folder where I saved the scan, you can see we've got all of our raw images from the camera. We've got our diffuse texture, a material object which we can ignore, and then we've got our actual lionscan.obj, which is what we want to import. Now we can see it's 261 megabytes, and that was only at normal detail level. Like I say, at high detail, this can easily get over to a gigabyte, which is an extreme sort of model to be working with. So if we hit import, we'll notice two things to begin with. The first thing we'll notice is it takes a little bit longer to import the model just because it's so big. If you went with high detail as well especially, it will take even longer. The second thing we'll notice when it appears, just like that, it is on its side. So the reason that RealityCapture exports things on its side like this is because it's built to work with game engines, specifically Unreal Engine. So Unreal Engine, as you may remember, has a different axes for up. So in Maya and most 3D sort of modeling softwares, Y is always the up axis. But in Unreal Engine, Unity, those sorts of things, Z is the up axis. So that's why it comes in slightly sideways. But now we can see, if we have a look at this model, let me just turn on the self-shadowing. We've got a really, really nice high quality model that if we click on, we can't make out anything because each of those lines is for a different polygon, which is crazy. So we can see from my heads up display up at the top, this has 2.5 million faces. Yep, 2,501,000, and it's a very, very high quality model. Now, if we want to put a texture on it, we can do it the usual way. Hold right click, go to assign new material. I'm going to do an Arnold standard surface shader. And in the attribute editor on my standard surface, I'm just going to go into base, go to the color, click on our little checker icon, go to file to import our image file. And then when we click on the image name folder, we can just go back to that same folder we were in and find our lion scan u1v1 diffuse.png. And if we open that up and make sure we click on our checkerball to display textures in the viewport, we can see that we've got all those textures. And we can relight this and do whatever we want to try and make it look exactly the way we want. Now, that is how to export the full quality model. Now let's go over another way of doing it, which might be a bit more optimized for the different things depending on what we're doing. Now, if we go to the Tools menu at the very, very end, which is under Scene 3D, we've got another option that we can do, and it's called Levels of Detail. Now, if you hover over, you can see it's called the LOD exporter, LOD just standing for Levels of Detail, and this is something that we use in games and game engines a lot to make sure that as we get really far away from an object, it doesn't stay at 1 million polygons or 2.5 million polygons, because when we are, I don't know, 500 meters away in a game and it's only taking up about 20 pixels of our screen, we don't need it to be 2.5 million polygons. That would be absurd. So, in games, they use something called levels of detail, which means as you get further away, it will become a lower polygon count and it will become more and more optimized to make sure it's not taking up too much resources. This can be useful for us in Maya as well. The higher polygon count, the longer something will take to render, and the heavier it will be in our scene in total, and it can slow Maya down. So if we click on the levels of detail button, now I've already got some images of some other scans that I've done. So I'm just going to make sure I'm back in that Nottingham Lion photo set folder. Now I'm going to call this lion scan underscore LOD, which it may add an extra LOD onto the name of this, but we'll find out. So I'm going to hit save, and then we get the option box come up. Now, we get a few extra settings in here because we're doing LODs. So I'm just going to open these 3 settings. So export textures, I'm going to say yes. It's always the first one I want to do. And now up at the top, we've got model count 3. And we've got relative simplification percentage 25%. So that means that it's going to create 3 models for us. And LOD 0, which is going to be our highest poly model, will be the full 2.5 million polygons. LOD 1, which is our second one, will be 25% lower in the polygon count. And LOD 2, which is the third model, will be another 25% lower from LOD 1. Now, I'm going to set this relative simplification percentage to be something really extreme. I'm going to set it to be 50%. And then with textures on, and make sure my mesh settings are set to wavefront object, I'm going to hit OK. Now this may take a bit longer because it's got to do more processing. It's got to export the very high polygon model. It then has to decimate our model and export a lower poly version of it. And then it has to decimate that one again and export that once more. So we'll come back once this is finished. And there we go, our export is finished. So if we go back into Maya, what I'm going to do is just delete this model for now and go File, Import, and we can see we've got a lot more models and different sort of textures and files in this folder now. So first thing I'm going to do is just import LOD 0, and then I'm going to rotate this to be flat on the ground again. And we've got our texture already linked just because we linked it with the last model. Cool. Now, I'm going to move this off into the distance because we've already seen this. Next, I'm going to import LOD1 OBJ, which we can see is roughly half the size, almost exactly half the size of LOD 0. So import, take this one as well. And we can see it looks almost the exact same, but it is lower polygon model. So if we click on it, we can see the selected faces. We've got 1,250,000 faces. So that is half the amount, and it is much more optimized. But we can see we can get some issues at the back here. But it's not something we'd be looking at, so that should be fine. And now let's import our last one, which is LOD 2. And we can see this again is just under half the size of LOD 1. 57 megabytes, which is substantially less than our 261 megabytes that we started at. So import, and that was much faster to import, and we can just rotate that again. And we can see they don't look all that different. So we've still got great amount of detail onto our model. You can still see it's a very high polygon model. We can still do plenty with this if we wanted to retopologize it, which we'll be doing in the next photogrammetry session. We can render this, we can paint extra textures on top, and all of them are great models to be able to work with, either for something super, super high detail that's close up to the camera that we have to work with like this. So this could handle a lot of extra sort of close-ups, and something that could be, I mean, not even that far away from the camera really. It can take up the full screen and it's still a pretty good quality model. So that is how we export in a more optimized way. Now this video has run a bit longer than I'd expected it to, but hopefully it's been helpful to you, and this is something that you can go out and get your own models and use it in your own projects. The next session on photogrammetry, we are going to be looking at retopology, so how to retopologize a model in Maya. So that basically means instead of having to work with all of these millions, if not hundreds of thousands of polygons, what we can do instead is just draw maybe a couple thousand out in a nice and clean way, and it can even mean that we can make it an animatable mesh. Because if we tried to animate this right now, it would be an utter mess and it would not look good at all. But we can make it look good, basically. The third photogrammetry session, there will not be a video for, because you are going to, in your lesson, take out some of the cameras, go into the city, and you are going to take some photographs to use in the photogrammetry software yourself and get some of that hands-on experience with collecting data sets. So hopefully this has been useful. I will make sure that you're all aware of this video for if you need to ever look back at it, if you've forgotten how to do this. And if there's anything else that you have any questions on, remember you can always email me, Teams me, comment on one of these videos, and I will try and get back to you or do a video on whatever it is as soon as possible. Thanks, guys.